All right, let's dive into the story of the original wonder drug, Penicillin G. It's an incredible tale full of lucky accidents, the pressures of war, and a microscopic battle that literally reshaped our world. To really grasp how huge penicillin was, you have to imagine the world before it. So let me ask you this. Rewind to the 1920s, before antibiotics. What do you think was one of the most common, most feared killers on the entire planet? The answer? It's kind of shocking. It was something as simple as a scrape you'd get in the garden. Before penicillin, a minor cut or a routine surgery could easily lead to a deadly infection. Things like sepsis or scarlet fever, they were often a death sentence. That was the reality. The stakes really couldn't have been higher. And that brings us to our first part, a chance discovery. See, the story of penicillin isn't about some grand, careful design. It's a story of a brilliant observation made right in the middle of a messy lab. Okay, what's really fascinating when you look at this timeline is the gap. Fleming spots the mold in 1928, right? But it takes more than 10 years, a whole decade, for the team at Oxford, led by Florey and Chain, to figure out how to actually isolate and purify this stuff. It wasn't until 1941 that they proved it worked in a person. That huge gap just shows you what a massive challenge it is to turn a cool observation into actual medicine. So what pushed it forward? Pure urgency. The absolute crisis of World War II is what took penicillin from a lab curiosity and turned it into a mass-produced lifesaver. On the battlefield, it was used to treat infected wounds, saving just countless soldiers who would have otherwise died from infection, not from their original injury. It really was the wonder drug of the war. Okay, so let's shift gears from the history to the science. How does this mold actually pull off its magic trick? What is its secret weapon? The whole trick, the entire secret, comes down to one key difference between our cells and bacterial cells. Our cells, they're flexible. But bacteria, they have this rigid, protective outer wall. Think of it like a suit of armor. And this armor is absolutely essential for them to survive. And that right there, that's the target. Penicillin is part of a class of antibiotics called beta-lactams. And their power source is right there in the name, a super-reactive structure called the beta-lactam ring. This little four-sided ring, you can think of it as the warhead on the missile. But here's the twist. The very thing that makes penicillin so incredibly deadly to bacteria, it's also its greatest weakness. As one source puts it, this beta-lactam ring is also its Achilles heel. It's not just a target for the bacteria's defenses, but also for things like our own stomach acid. We'll get back to that. So how does the takedown actually happen? Well, think of a bacteria like it's a construction site. It's using this special enzyme, a tool called transpeptidase, to build its wall. Penicillin comes along, and its beta-lactam ring looks just like the material this tool is supposed to grab. So it tricks the enzyme, latches on permanently, and basically breaks the tool. With construction shut down, the wall gets weaker and weaker. Pressure builds up inside, and boom, the bacterial cell just ruptures and dies. It's a brilliantly targeted attack. Now, because that mechanism is so targeted, Penicillin G is still an absolutely crucial medical tool, even after all these years. But its use today has become very, very specific. Let's take a look at how doctors actually wield it now. Penicillin G has a very specific hit list. It is still the #1 first-line defense for serious infections like strep throat and pneumonia. It's the go-to for the bacteria that causes meningitis, and most critically, it is still the undisputed gold standard treatment for all stages of syphilis. Okay, remember that Achilles heel we were talking about? This is where it really comes into play. Penicillin G is so fragile that our stomach acid just completely destroys it. And that's why you can't take it as a pill. It has to be given as an injection, either right into your vein with an IV or as a shot into the muscle. To work around that problem, scientists got really clever and developed different versions. Crystalline Penicillin G is the fast-acting one you get by IV in the hospital. It gives a huge punch, but it's gone in about 30 minutes. Then you've got Procaine Penicillin G, a shot that lasts for about a day. And then there's the long-acting champion, Benzylpenicillin Penicillin G. 4 weeks. Just think about that. A single shot in the muscle of Benzylpenicillin Penicillin G can keep working in the body for up to 4 weeks. This is an absolute game changer for treating diseases like syphilis because it makes sure the patient gets the full course of treatment with just 1 dose. But here's the thing. For as long as we've been using penicillin to attack bacteria, the bacteria have been evolving to fight back. And this brings us to the biggest conflict in this drug's story today, the rise of resistance. So you have to understand, bacteria have a playbook. Their number one move is to create an enzyme, basically their own weapon, called beta-lactamase. Its only job is to find that beta-lactam ring on penicillin and break it, turning our drug off. Other bacteria have evolved to just change the shape of their construction tool, so penicillin can't grab onto it anymore. And some just build a fortress, a thick outer wall that the drug can't even get through in the first place. So with all this resistance, you might be thinking, well, is penicillin's story basically over? And the answer is no, not even close. Let's talk about its irreplaceable legacy and why this original wonder drug is still so important. Here's the bottom line. Even with all the challenges, for certain life-threatening infections, and I'm talking specifically about syphilis and meningococcal meningitis, Penicillin G is still the absolute best weapon we have, period. For those diseases, it is truly irreplaceable. Its list of targets might have gotten smaller, but its importance absolutely has not. And that leaves us with this final thought. Penicillin G kicked off the antibiotic revolution, an age that has saved millions upon millions of lives and made modern medicine possible. But as the bacteria it used to defeat so easily continue to learn and fight back, the real question we have to ask ourselves is, what are we going to do to make sure that this revolution and the incredible power of this drug doesn't just come to an end?